Good morning. I'll give you a couple of seconds for latecomers. Good morning, everyone. Thanks for coming at that crazy hour in the morning after the party. So, okay, let's get started. My name is Tomek. I'm Tomek Cejner. I have Twitter account and I have a job. And I do software, despite the name. And I'm an iOS developer, and sometimes I'm interested in security, and it's by necessity, and I'm also have some interest in hacking. But by no means I'm not professional expert, not expert on cryptography. If you want to know something about encryption, keys, key derivation functions, go to Marcin's presentation. What I think I will say that if you leave that presentation board that you say, I know everything, that means you are in pretty good shape when it comes of app security. And I want to talk about what's important when building a software product. And I risk saying that it's not the scale, not the performance, but the trust. The trust that your customers have in you. It's especially important because there are some famous data breaches that go to mainstream media, and that data breaches may cause that you lose the trust, which is very hard to regain. And if something can harm your business, it's probably leaving customers jumping off the ship and the salespeople from competing companies trying to poach them. So what drives us to make our systems more secure? Of course, you care, your internal driver, you care about your users, about security, but also you can have external driver. If you are lucky, let's say lucky enough to have big customers, like big enterprises, they have a tendency to come to you just before signing the contract, and they start asking questions. And they might start asking very difficult, tough questions. So you can consider all this, my presentation also as a preparation course for meeting with the sad, serious men in suits that will want to audit you. But worry not. iOS is our friend, and it comes some nice techniques to protect network communication, protect the data store, and protect your secrets. So let's start with network communication. So ATS, everybody knows, App Transport Security. It's introduced in iOS 9 and enforces some certain level of security at transport layer. For example, there are the requirements, there are a couple of them, but most important that you have to use HTTPS, so the communication is encrypted. HTTPS alone is not enough. You have to have trusted certificates. And TLS, transport layer security, is the protocol of establishing the secure communication. It's required to be at least in version 1.2. It's like almost the current version, and it's known to not have major problems. The earlier versions, TLS 1.0 and SSL, which is predecessor, has so many vulnerabilities, they even went to mainstream media. And there are other requirements like strength of cryptography. This is something you can check for yourself. The ATS, in case you are dealing with legacy systems, you can add some exceptions to ATS. So For example, you can add the exception globally in the app, or you can add exception for specific domains you are communicating with. For example, you have to, I don't know, download weather charts from some government agency, and they not yet implemented HTTPS. But you should know that Apple will probably start asking questions if you want to disable ATS globally or in parts. And there are two basic ways of disabling. This is the entry in plist ns allow arbitrary loads that disables ATS completely, and you should probably have guarantee that Apple will ask for better justification. And you can also leave the ATS but just allow HTTP loads. But as I said, the Apple claims that will ask questions, but it may happen that, for example, if you do some debugging, working with development environment, just make sure if you temporarily disabled ATS, make sure it doesn't go into production app. And it probably happens to everyone. In communication between app and its backend, it's important to mind the man in the middle. Who's the man in the middle? The man in the middle is the typical hacker, like on that picture. So this is young male in hoodie, in dark room, working on great laptop because he doesn't have to use the power and he has on Wi-Fi. Or maybe, no, that one is more professional. He wears a mask just in case FBI peeks through the webcam of the laptop. So in typical case, the app is communicating with backend servers, and then hacker comes. And he tries to intercept the communications. There are many ways of doing that. You can set up free Wi-Fi. He can hack into your router and sit in the middle. But we are covered because we have certificates, so the encryption is end-to-end, so the attacker can only see the nonsense sequence of bytes and cannot eavesdrop any communication. But what if an attacker creates its own certificate and tricks your app into connecting into his server, not the legit one, by just poisoning the DNS or hacking the DNS services? But still, that's not that bad, because the certificate is fake, and it's easy to say that certificate is fake because it's probably self-signed. Because no one will issue a certificate for the domain to someone else, unless the certificate authority is hacked itself. But it's maybe not enough, because if the hacker is determined enough, he can install onto your device a certificate authority cert on your device and make this fake certificate actually legit. And this is you can do in goodwill. If you want to debug SSL communication, this is what you exactly do. The proxies, like Charles proxy or MITM proxy, they also include certificate to install on your device, so you can safely hack yourself. But in order to tighten it a little, you can use a technique called certificate pinning. It's very simple. You just put in the simplest implementation, just put the copy of certificate in the app bundle. You compare who are you connecting with. And fake is easily detected. You can just bail out. So easiest way of pinning is against certificate, which may be tricky. And also there's a way of pinning a certificate by public key, because the certificates are set to expire in some time. It can be 2 years, 3 years, but in case of some services, the certificates are refreshed very often, like every month. And you would be forced to resubmit, republish the app every time the SSL certificate is renewed. So it happens more often. You can paint not against the whole certificate, but by the key used to sign that certificate. The difference is that pinning, plain certificate pinning is very easy. The popular frameworks like Alamo Fire support this with just a couple of lines of code and placing the certificate in the bundle. But again, this may be a little tricky because the time frames can be longer, like 2 years from now, and you have to establish some process because probably people responsible for a certificate are not the people who develop the app. So you have to be aware that the certificate is expiring. There is usually an overlapping window when the old and new certificate is still valid, and during that very window, make a app release. And key-pinning will work, of course, if the key used to sign your certificate will not change. And if you are a little more paranoid, or your customers are, there's a possibility to set up VPN specifically for your app. This is done through mobile device management software. There are many of vendors of MDM solutions. This is supported by iOS out of the box, and it absolutely requires no development from you. It's completely transparent. You might just know to tell your customers they can use MDM to tighten the security a little bit. Okay, let's talk about data store security or the file system. So, as you may know, everything in file system is encrypted. And the scheme of this encryption is pretty sophisticated, as each file has its own key, which is stored in file metadata. And that file metadata is also encrypted with the file system key. And that itself do not offer much protection, but it's used for interesting purpose, for remote wipe of device. Because if you destroy the file system key, all other keys are unreadable, and the files are just a random sequence of bytes, and they technically not available. This is especially important because cleaning, erasing the flash storage is not that easy. And the keys are also stored in special kind of storage, which gives more guarantee for successful removal. But the full view of the encryption scheme looks that way, that also every file has its own, it's called protection class. And the class key is also encrypted by key, which is a compound is entangled of hardware key, which is based on hardware UID. This is the unique identifier which is burned somewhere in the silicon. No one knows what is the key, even Apple. And the passcode key, which entropy comes from your passcode. So as you might guess, longer the password you have, the better entropy. And that also means that if you want to brute force attack, for example, if many of you might have 4-digit password, it's 10,000 combination. Apple delays the decryption. Each attempt will try at least 80 milliseconds, but it's nothing when you have only 10,000 combinations. So there are another measures slowing down, and because it's tangled with hardware key, the decryption attempt can be only done on device. You cannot image the flash and use some powerful computer to try to decrypt the storage. And the protection classes, there are 4 of them. The first is NS file protection complete. It means that the keys, encryption keys, are alive only during the moment the device is unlocked. Once you lock the device, the key is destroyed, and in order to access the file, you need new key. And to get new key, you have to enter passcode. It may be a little uncomfortable if you want to do some background processing. So there's other protection class that after locking a device, the key is not destroyed, but only as long as the file you're accessing are open. when you close .files, the associated keys are discarded, and reopening will not help. So this is something useful when you want to finish some background processing. And default file protection, if you don't specify for the file, is the longer name, is file protection complete until user first authentication. This is the simplest scheme. It means that the key is not discarded after device is locked, and it stays here until the device is rebooted. So it protects you against attacks which require a reboot of device. It's also good to know that if you know that your device is going to be stolen in the moment, or you get robbed, or you are politically active and law enforcement wants to grab the device from you, you should shut it off immediately, and for most of the apps, for most of the data, you will be safe. There's also non-file protection at all, so using only file system keys, probably you don't want to do this. So there are delegate methods. If you are interested in event that the device is about to be locked and the file you have been accessing will be no longer accessible, there are UI application delegate methods that will be called when device is about to be locked, and the opposite when the device has been just unlocked. But mind that the documents folder is still backed up. The backup may be in iCloud. The backup may be on your computer. And even worse, the backup may be unencrypted. So if attacker gets access to the backup file, it can be browsed. The software is available. You can be browsed, and all the files on app sandboxes are available to see. So you can put some sensitive data into caches, but mind that the caches can be emptied at any time by iOS, or set a specific attribute. URL is excluded from backup, so to exclude some specific files in documents folder from backup. Secrets. The apps have secrets. And the place of storing secrets is a keychain. Fortunately, the keychain is available for developers. It's a great place to store small amounts of sensitive data securely. For example, passwords. And there's an API for the keychain. It's pretty low level. I guess it's hardcore low level. It's C API, and you probably want to use a wrapper. There are many wrappers on GitHub on CocoaPods. Probably the count close to a number of JSON mappers. And the keychain can be considered as a simple database. You can add item, update, delete, or retrieve, which is called the copy matching. Retrieving is like making a query to database, and all these functions accept a dictionary as a parameter. And in a dictionary, you set actually something like query parameters. The scheme is elaborate because you can have different classes of storage. You can differentiate the keys by users. For example, you can make sure that the keychain item is available only to specific users, or separate the keychain items by some services you may have in the app. And the last attribute is particularly interesting because it offers something similar to protection classes which are for the file system. And the protection classes, like the default one, is accessible when unlocked. So you might guess that you can read the keychain item only when the device is unlocked. Accessible after first unlock is equivalent of the default protection class for file system. So the keychain item is available after unlock, and it's there until the reboot. So if you need to do some background processing, use the confidential data from keychain. For background processing, you can set this protection class. There's also unrecommended, always accessible. And the last one is particularly interesting. It's makes the keychain item accessible only when the device has set a passcode. And that fourth option will fail if device has no passcode. And if the passcode is set and later then user decides to remove the passcode, all keychain items with that last class will be removed. For additional security, all these constants have variants with this device only, which means that when the device is backed up and then restored, so we can ask that the keychain items will be restored only to the same device which were they backed up from. So in other words, to prevent migration of the keychain items. So keychain looks like a great way of storing user credentials, right? You can ask for login and password. Oh, sorry. Well, it doesn't play, sorry. But the answer is no. God, no. Oh, maybe not that strong. Whenever it's possible, because it's not always possible, but if you control the backend, if you have some possibility to influence the development of the backend, you may want to use OAuth 2.0 instead. It's a very simple protocol and brings much more safety than keeping the username and passwords even in most secure storage on device. To put it simply, well, the OAuth 2.0 offers a couple of flows. They are correctly called grants, and there are two most popular grants. One is called authorization code, and I guess you are familiar with that. This is a flow which is used where you, for example, authenticate with Facebook. So the app wants to makes a call to authorization server, says, hey, I have user who wants to authorize, here's login and password. And authorization server says, hold on, I don't know what the password is. Let's go to the web browser and let user enter the credentials on the trusted login website. So the user enters the credentials and the web browser is redirecting back with something called authorization code. It's not yet access token, it's a short-living authorization code. And the app goes back to authorization server and says, okay, I was successfully authorized, so this is my authorization code. Can I have an access token? And server says, sure, this is your access token. And then you sign all the API calls with the access token. The process is very simple. You just add additional HTTP header, and you get the data back. This is a little elaborate, but it has some nice properties. The app doesn't know about password. It doesn't even need to see the password for a brief moment. You have your users can trust because they only enter the credential on the trusted place, in the trusted place, and the access tokens are completely opaque. There are in no way you can derive the username and password. There are just random strings of hexadecimal digits, and those access tokens can be easily discarded or revoked. For example, in that way you can also manage apps. For example, if the Android version of your app has a security problem, because the iOS will never have, right? You can disable all tokens issued to Android apps and leave the other which are considered secure alone working. But this redirecting to a browser may be a little cumbersome, So there is also a simplified grant. It's called user credentials, and it's recommended for first-party apps. So if you are, for example, Twitter, and you build your Twitter app, you don't have to dance between web browser and the app, because users know this is the legit official app. So in that case, you can make it much simpler. You just get the login and password from user in the app, send to authorization server, get access token back, and make API calls as usual. The OAuth 2.0 is simple because all its security is based on transport security. So it relies strictly on HTTPS as a secure channel. The previous incarnation of OAuth involved much more cryptography, signing, and it was more difficult to implement. The OAuth 2.0 is very simple to implement, even using popular networking libraries which do not support OAuth 2.0 directly, but it's easy to add. But the access token can be hijacked. For example, the communication channel is compromised, or the device keychain is compromised, or you just didn't use you were careless and you didn't use the device keychain and the key leaked somehow. So the answer for hijacked access token, because in order to prevent from random hacker to access the API, is to use the refresh tokens. Refresh tokens are connected with the expiration of the access token. So you set the access token to expire in some time. It may be a day, which is maybe not a good idea, but half an hour or 15 minutes if you want to be very strict. So you make API call as usual, and suddenly the API call fails, and you get a response suggesting that your token has expired. And along with access token, you received the refresh token. So you go to the authorization server with that access token, with that refresh token, and say, hey, my token expired. Can you give me a new one? Of course I can, because the refresh token is an additional secret. And you continue making API calls as usual. This may be a little tricky to implement because your app has to be prepared that any API call will fail at any time, and you have to repeat that the same API call. If the process of refreshing token goes smoothly, your users will probably never notice that their token has expired. So we can make hackers' life a little harder by introducing refresh tokens. Another interesting technology in iOS is local authentication. So as a developer, you can make use of the passcode or biometric identification like Touch ID or Face ID. And, well, let's look at the code example. You just create an authentication context and do some boilerplate, and effectively you can provide a callback function which accepts two parameters, success and error. And the success, if success is true, that means that when this code is called, the iOS brings up the Touch ID confirmation dialog, and if you Touch ID or enter passcode, if you were successful, then success is set to true, so you can navigate to the next view controller, which contains some sensitive. So it's a matter of simple if. So you can say that you can easily protect sensitive areas of the app and use the benefits of biometrics. But you can say, I'm a startup, I don't need such yeah, I know this is the if, but I'm only making a photo sharing app for dogs, and what can go wrong? Of course, there can be some data breach leak and your customers will be disappointed. So that kind of security is called security by obscurity. So this is like you're letting someone through the locked door and ask him to close their eyes, and you just open the door, and they don't know. You didn't have to use any key. So maybe a pro tip, use some cryptography, if you learn how to do it, to protect data. And the good news is, this is not a code example, I didn't want to bore you. The good news is that the local authentication framework can play together with the keychain. So in another code example, this is the similar piece of code to querying the keychain items. And you can add the attribute I bold-faced on this slide, add access control. So you can demand user presence. So every time you fetch the some sensitive from the keychain, iOS will bring up the authentication dialog, and you use the fingerprint, your face, or passcode. And then in that keychain you can store, for example, cryptographic key used to encrypt the data. And this is how probably most of the banking application works, because the data is unreadable and the key is protected by user-entered passwords. But as I said in the beginning, when you are lucky to sign the contracts with the big enterprise, they might start asking questions. And I can tell you in secret that some of the big enterprise are really paranoid, and may be good to be prepared. But a little paranoia will not harm anyone, right? So you can make sure that logs are clean, so you do not leak anything sensitive to logs. Access tokens, sensitive data, mind the GDPR and the huge fines, and especially on production. You may also be concerned about custom keyboards, because actually I know the extensions undergo the review, but nothing can stop to custom keyboard to leak some sensitive information. And there's a way to disallow the custom keyboards in the app. The other popular protection is preventing screenshot of the app when going to background. If you switch, switch between apps, you see the nice thumbnails of each app running currently on device. So it's made in optimized way, so the iOS is taking a screenshot just before going to the background. And it is possible to capture that moment and replace your screen, which may contain some state of your bank account, with some splash screen and your logo. And this is something all banking applications I know are doing. And your customers also might be concerned about that. Cross-site scripting. Okay, cross-site scripting, you may think this is concern on the web. Yes, that's true. You probably are not able to do harm with JavaScript in native iOS app, but it's good to remember that depends on architecture of your system. There may be separate backend for frontends for the web and the mobile. And the sanitization of user input, the protection against cross-site scripting, it may happen. It is performed only in the web stack, and nobody is checking what mobile users are entering, because it may go different path. And attacker might try to side channel and enter JavaScript, inject JavaScript using the mobile apps. So how do I get there? How do I make my app secure? It's good to start with defining a threat model, because there is no such thing like absolute security of the app. If we have attacker with enough skills, enough funding, and enough time, he can try to break anything. So you have to put yourself somewhere between photo sharing app for dogs and apps for government, put yourself somewhere in the middle and define what do you want to defend against. You can also do a security audit. You can play, have fun and hack yourself, or you can hire someone to hack you. You can also, of course, read. The OWASP is the Open Web Application Security Project, is an open initiative, which goal is to empower the culture of building secure software. And they published OWASP Mobile Top 10. Who knows about Mobile Top 10? Yes, a couple of hands. There is the equivalent, it's for the web. It's much more popular, I guess. And you can think that it's a good checklist for mobile security. No. This is the Mobile Top 10 is like leisure read, is an awareness document. So we can show this to some stakeholders to introduce, is a step into bringing a culture of producing secure code in your organization. If you really want to thoroughly check your system, your app for security issues, I suggest reading also this document published by OWASP. It's called Mobile Application Security Verification Standard. There's a similar document for the websites without the word mobile in front. And it covers, it's a long checklist, and it covers authentication, data storage, network, even code quality, and the build process. And some of the warnings I stated in my presentation are listed, actually all of them are listed in that document, but I, of course, didn't have chance to mention everything. And like Onion, the MASVS is divided into layers. So we have L1, which is recommendation, verifications for the general standard application. If you deal with sensitive data, you can also tick checks of the defense in depth, second layer. And if you're really concerned about your app, there's also R level for resiliency against the tampering or reverse engineering. Very interesting read. And so summary. So just find a balance, because the greater security comes with worse user experience. So you don't want to ruin the user experience, and you have its art of finding the right balance between security and ease of use. And most of all, don't let down your users, because they trust you. Thank you. If there are any questions, I'm available all the time on the corridor, so feel free to ask about, talk about some hacking, anything else. Thank you.